Now we shall assemble a working circuit of the buffer gate using a switch. Let's bring in our breadboard. The first item we shall connect on the breadboard is the switch. It can be placed almost anywhere on the breadboard, but for our example we shall place it here, and then magnify the image. The switch which we are using is referred to as a push switch. To make it work we need to press and hold it down. When it is released, it is automatically switched off. You may recall that this area contains nodes, strips of connectors running vertically, but they are all separate and not connected together. If we look at the schematic diagram, we can see a link between the positive rail and the left-hand side of the switch. The positive area on the breadboard is this row of connectors. So we can make a link from any of the connectors on the top row to the left-hand side of the switch. Remember, the nodes on the left-hand side of the switch are all connected together. Next is the safety resistor for the LED. Without this, the LED would burn out. We can see several bands of coloured strips on this component. This is used to identify the value of the resistor. The first band is red. We can consult the table and we can see that red is equal to 2. Next is black, and this is equal to 0. Finally, the last band is what we refer to as the multiplier. This is red, which is 100. So the final value of this resistor is 20 times 100, which is equal to 2000 ohms or 2K. We won't worry too much at this stage about these values of these components, more about these later. The component is used to resist the flow of current and to protect our LED. We can see that it is connected to the right hand side of the switch. Next item is the LED. Here is the symbol we shall be using. This is an actual LED, and notice that one leg is longer than the other. This is so we can identify the positive side of this device. If it is connected the wrong way around, it can be damaged. If we check the schematic diagram, we can see that the positive side of the LED is connected to the resistor. Finally, the other end of the LED is connected to the negative rail. Now let's analyse how this circuit will behave. First with the schematic diagram. The battery is connected and current flows to the switch, which is opened. Now with the breadboard. First we connect the power. Current flows through the top rail. Then down the link to the node that is connected to the left of the switch. Since this switch is opened, the LED fails to light. So with a buffer logic gate, when the input is 0, the output is also 0. Let's reset the circuit and close the switch. Current flows to and through the switch, through the protection resistor, the LED, and back to the negative of the battery, which completes the circuit and the LED lights. On the breadboard, the switch is closed. Current flows through the top rail and down to the switch. Since it is closed, current can now flow through the switch, through the resistor, through the LED and back to the negative, causing the LED to light. So when the input is 1, the output is 1.